Alright, so welcome to Work with Gabriel. And in this module, we're going to be talking about the networking commands because networking is also so essential in Linux system. You need to understand the basics of networking commands and how it works. Okay, let's just go ahead and dive right in. Let's just open the terminal here if I can have fun. Alright, so let's just look at the networking commands that we are going to be having. Networking commands that we are going to be showing. This module I do not include anything about networking, any basics of networking, but it is very essential. I give a brief introductory to networking. So what is a network? A network is just a series of computers that are interconnected together in order to share resources, to share information. So just think of it like that. And for one computer to talk to another computer, they need something called a protocol. Not so like computers are not just like we human being that we can just open our mouth anytime and talk. Computer is not like that. Before they can talk, they have protocols. So protocols are the rules or a set of rules that guide a communication to take place between one computer to another computer. And also the way we identify ourselves by name, computer also knows how to identify themselves by something called an IP. So an IP stands from Internet Protocol. So it's a series of 32 bits number to 128 bits because we have IP two versions of IP. So let me just type as I'm talking. So, we say protocols. I said they are rules that actually guide computers computer to communicate to communicate with each other. So not unlike human beings. So that is actually what protocol is. And network itself, it's actually a connection of interconnected computers. So they are just connected in order to share resources. So resources can be printer, it can be images, can be photos, can be anything over the internet. So also I think I said they have names, they have identifier which is called an IP address. So we usually call it an IP address. It usually look like these 10 two dots this dot dash. So it's actually a 8 bit number separated with dot. So this is 8 bit plus 8 bits, that's 16, plus 8 bits plus another 8 bit, that's 32. That's why I say they are always a 32 bits in number. So they are always 32 bits in number like that. So that is IP. So we have two versions of IP. We have IP version 4, which is actually this kind of example I gave. So that is written like this. So that's IP version 4. And we have IP version 6. So I'm giving very basics of networking right here. We have IP version 6. And networking is a very big course on its own, and that is why it's essential to take CCNA. And I don't have a course of CCNA yet, but in future I'm planning to have a course on CCNA. So just in case you want to brush your hacking skills with a lot of networking, they just go ahead and dive right in. But it's just very okay if you have very little bit of knowledge about networking. It's so alright. So that is what I'm giving you. So that one actually works like this. Let me just try Ifconfig. Okay. So this is just an example of our IP version. Let me just version 6, Control V like that. So this is also an example of IP version 6. I think all this guide that you started into 0 can be changed to 0000 because that's actually what it meant. So we have 1, 2, 3, 4, 5, 6. I think it should be. Does it to be 6 or 8 number? So that's actually how IP version 6 is specifically. Okay, all right. So let's just go ahead and continue. So I said they have set of protocols. So what are protocols now? So we've talked about protocols. They are rules to for the guides computers to communicate to one another. And one thing you need to learn about networking is that for a communication to take place, there's going to be a host and a client. So we also have a host. So sorry, let's say a server, and a client. So it is so important, so which means that someone is going to host the network and someone is going to be ready to connect to it. So we have two basic principles of protocols that guide the internet of a thing, which is TCP, which stands for transmission communication protocol. So it's actually was connection oriented, which means that the transmission of connection while we try to use this kind of protocol, the transmission of connection with while we try to use kind of protocol, they are reliable, which means that we are very very sure that okay, the other hand have the information we sent, and also we receive the information the other end sent to us. TCP is just reliable. Just understand that okay, it is reliable. It's like when you are communicating one on one, you are trying to maintain a handshake with someone. So we have UDP, which stands for User Datagram Protocol. It is not reliable, so there is no way for you to validate if whatsoever information that you are sending is actually reaching out to the other hand. You are just talking, like just talking. For now, I can use myself as a UDP because right now I'm not able to see my students, and I can you can't have me question. I can ask you question not until you comment or you inbox me specifically through social media. That is when we're going to communicate. So what I'm just doing right now is acting like a UDP protocol, user datagram protocol. I'm just trying to send information out and out for you. So I think those are the basics that you need to understand for now. And also we have something called MAC address. So out of the things that the system used to identify themselves is also MAC address. So MAC address is actually born inside your adapter. So it's actually came with the system. It used to came with the system. These are the example of it right here. So we have ETA blah 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 4A4 blah blah blah. So this is essentially a MAC address like that. So that's one thing I wanted to understand. Is a MAC address like that on its own. Um, okay, just in case this thing is small, let me just view it. So essentially, I view it. How do I view this one? How do I view it? Is there any way to view it? I don't think so. It's just there like that, just staring at me like that. All right, so uh, that's it. That's actually the basics that you need to understand. So the MAC address are always born in. They came along with your system, so they are just there permanently to identify your hardware. So that is actually how it works. So those are the brief introductory that I want to give about networking. If there is let me so any place we reach that actually uh, that's actually important for me to go through deeper into networking, then I'm going to just branch and then come in, then we're going to switch side, but I'll make sure we explain everything. So let's just go into networking command. The first networking command I want to introduce you to is Ifconfig. The second one is ping. Okay. The third one is IP. Okay. The fourth one is netstart. The third one is Nmap, which is a networking mapper too. The fourth one is trace routes. I think. All right. Let me just put that. These trace routes. Is there any one also that I also want to? Well, along the lecture, if I could remember any of it that I want to share you, but I think for now those are the ones that are important. So let's just go ahead and dive right in. So the first command is ifconfig. So ifconfig actually it's similar to window. When you open your window, you can also type ipconfig. And if you ask like what is ifconfig, it shows is to configure a network interface. So the question is now that what is network interface? Network interface is actually your hardware, your Wi-Fi adapter. Like now, if you can see from here, this is my network interface. So I have docker 0. This is my network interface. I have ETA 0, my network interface. I have loopback. I have this LX CBR 0. I have this USB 0, which is one I am using currently, and I have this WLAN 0, which is wireless. This is my Wi-Fi adapter. So all these adapters actually they are created. Most of them are created like this. Is actually built in. This guy is actually with my USB ports, and this is actually my Wi-Fi. So all these guys one by one, they are your interface. So to configure them, we use the if config for a command like that. So when you type if config, it's going to view all this for us. So that is what the if config do. And some informations are actually here that are supposed to show, are supposed to emphasize on. Okay, let's go to this guy that I'm using right here. This interface, because I'm using USB interface right now. As you can see, it's saying I'm having a flag of 4163, which is, we can ignore that. So this up means that the interface is up and I'm using it presently. It means that it supports a broadcast message. A broadcast message means that I can actually send a broadcast packet through this interface to any other devices that are connected around me. Probably we are on the same network. Then also it said it's running presently, which is true, that is running presently and I'm using it. And also it supports multicast. So multicast is actually a packet that is sent to a group of host device, like hosts in the on a network. So that's actually what the multicast is. And what is the MTU? That's maximum transmission unit. These are the amount of bytes that we can send so you just see transmission unit at the same time like that. So that is the maximum that we can set. The inet here simplify my IP address on the network. So I just connected the USB to my phone, then I on the USB touching on the, let me say the USB hotspot on my Android device. Then that is why then the my Android device has a DNS server, that is domain name service. Have it for me. Then it's automatically resolved this IP address for me. So it gave me this IP address of 192.168.43.31, sorry, 0.131 like that. So this next marks is actually my subnet. So what is actually a subnet? My subnet is actually the range of assignable IP address that is available within my network. So what do I mean by assignable IP address within my network? Well, just because right now it's only me that is connected to the Android phone. So by looking at this subnet, we can realize that so many kind of device, let me say a limited amount of device also can also connect to this network of a thing. So and the only way we can actually know that is through our subnet. uh, if you want to look at this, since I'm using 255.255.255, which means all these guys are hosts, the network bits, they are the network information right here. So 255 means that the network has taken that, the network take that, the network take that, and all I have is assignable from 1 to 255. So how do I know the number of device that can connect to this? There you can just do a simple calculation from here. So we can just say, all right, since I have 1 to 255, so which, sorry, that's 255, which we are going to leave one for we are going to leave one for the network. So that is why I said 1 to 255. So I can say the number of usable IP address is equals to definitely to 224 like that. So 224 devices, 224 devices is the amount of device that can connect to this my little network that I have before me. And that is why sorry, that is why subnetting, or let me say knowledge about networking is also very very essential. But with this brief information that I give, just know that subnet mask allow us to, they call it net mask, but it's actually also called subnet mask. Actually allow us to know the number of assignable IP address that our network can actually address to a device. So the number of devices our network can actually entertain or contain like that. And a broadcast IP address. So this broadcast IP address, so this probably due to my calculation this is wrong, because I need to minus broadcast IP address from here. So gas should be 2 minus 1, and the number of assignable network should be possibly 223 like that. Okay, so this broadcast IP address shows that this is the IP address that anyone is going to use within the network to send a broadcast message, probably our host, our router, because right now my Android phone is serving as my router because it's actually the one that provides the network interface for us to utilize. So IP version 6, so this is the IP version 6 of me on this network, which is also is it does nothing but work similar to IP version 4. So it's just like the reason why the implementation of IP version 6 is that people we actually run out of address space through IP version 4, which means that due to this very few limited number of devices that the network can contain, there is a need to expand it to make it more robust or vast in nature. So that's why they implement IP version 6. So by using IP version 6, which is 128 bits in number, it's really make a lot of sense. It creates enough large number of spaces, address space for host and device, all devices to have on the network, so which is very important. And this ETA right here, it shows my MAC address on the system. So the MAC address that my interface is actually using, my USB interface is using, so that is it out there. So the queue length, this is my queue length, is actually 1000 length that I can go. And also the RX, which is my RX packet that I think this is actually showing the rates of which I am sending packets in and out of the interface. So which means I have actually used 1.9 gigabytes. Wow, I don't even know that. All right, I've used 1.9 gigabytes, maybe sending in and coming in and so on, 500 and point something megabyte of it in. So overruns like that. So number of collisions, there is no collisions, there is no carrier, there is no overrun. You might not understand that, but the ones that are very essential I've put in. Once again, I will be creating a networking tutorial on its own, whereby you're going to learn about network in a very vast way. So you can just go ahead and stick to it. If you register for it, then I'll prepare the course, then send it over to you. Then you can just attend the course and match it up with your ethical working knowledge and let everything fly up. All right. So if you type Ifconfig again, it's going to show us the all these informations about our interfaces. You can see, you can check all of them one by one. All right. So that's all for that. That's stuff for that. So another thing is ping. So the ping command actually allows us to know if a host is on, if a network is on or is dead. So let me just ping. Let's pick google.com. So if google.com is actually talking back to us, it means that google.com is actually alive, as you can see right here. It's actually talking back. It says it's the 54 bytes from this what's it called, this service from Google, and give us the IP address, and it's taking and it's giving us the time to leave. This is TTL, time to leave, the sequence of this information that we are sending through and flow, which means that google.com is on. What if I try to pick something that is not on? Let me say an address that is 10.10.10.10. I know this address is not on, or it's actually on. Wow, so 10.10 is on my system. That's weird. Right, let's do something that is not on. Okay, let me say codewithgabriel.com, which is actually one of my website I'm trying to do. Is it talking? I think it's talking because it actually redirects me to somewhere. I want to ping something that doesn't exist on my, okay, if config. Let me ping this IP address. And I'm going to change this to 2 because I know that doesn't exist. You can see, because it doesn't exist on the network, is giving us that the destination host is unreachable. This is actually what I want to show you, that once it is not actually, well, it ping actually let us understand that, right, this is something is working, something is not working, and all it's doing is just sending an IPMCA code to, it's saying that is internet communication message protocol. If I am right, yes, I'm right. It's sending it to an IP address on the network to test if the host is on or it is off. All right, let's go to another command. So I'll just put the asterisk on the ones I've actually explained. All right, the IP command works more or less like the ifconfig, except that it allows us to do more things. So if I say IP like that, it gives me some options that I'm going to use, it some rules. So if I say IP man IP like that, so it say I can use dash b dash a. You can use all this information there. You can use dash 6 shorten for address family 6, which is IP version 6, IP version 4. We can use this to manipulate all sort of things. We can say L, you say execute over all subject or something, and then the command syntax, we can use address for address, we can use link for link, we can use MAC address for multicast address, we can use monitor, we can use route. So let's just use some things like address. So we can say IP address, so which is e address. You can see it shows nothing, but it gives us the information about our interface. Say we have interface loopback 0, you can see more or less like the same information. So this is the USB, the same information we have the other time. Then our IP address plus 24, which is our subnet, the broadcast address, and the MAC address of a thing. So the IP address also show us more or less of the same information. So IP, then if you hit tab, I hit tab, so it shows some information. We can show routes. If we show routes, so it's going to show us our routes. So these are our routes. We have this IP, the 10.10 networks plus 24, which is taking on this interface. So LXCBR0 protocol kernel or something like that. So we have this our address right here that I'm using on my USB port, which is actually taking the device of USB 0 protocol kernel, so forth like that. Yes, I'm talking too much. I think I need to stop from there. All right, the net stats. So the net stats actually show us the statistics about our network, which is so essential. So if I go like net stats, okay, let me just clear this. The net stats command, this is just going to show a lot of services and network, let me say network services that is running within the system. And as you can see, we have tons of information right here, tons of information of network that is running, which is specifically doesn't really mean to be it doesn't really mean to be us running it. You can see even the system itself is running a lot of network informations right here. So if you want to see some network informations that we are running that is specific to UDP or TCP, you remember, so we can do net start, then tag U and D. So it gives us the UDP that is running. So UDP, we need to add C, the UDP. So it's a UDP 6, that's our address on version 6. So we have all this information that is running, which is established. So WhatsApp, so I have this information from WhatsApp that is running to from TCP, which is using TCP protocol. This is using a UDP protocol. I think you understand this now, because I've actually explained what UDP and TCP is specifically. I've tried to make more emphasis on that. Alright, so let us move to the next command. So the next command we're having is Nmap. So Nmap allows us to map network. It's actually a shortcut for network mapper. So to we can you actually use it to know what is up with our network. So let's say Nmap, then followed by our local IP address 127.no.no.1. Then all it's going to do is just going to give us information on what is running, whatsoever services we are running on our system specifically. So if you look at it, it says we have a port 5432 TCP open and it's using PostgreSQL. Alright, I think I've never explained something like port, so let's just go on here. So what is port specifically? Anyway, port is actually a number that identify each of the services protocol that our network is running in order to pass through information through that particular port. So just think of it, after having the address of machine A and machine B, so they need a port in which for the data, for the exchange of data or exchange of communication to take place. Just like we human being, if you want to send a telegram or a message or a mail from one post office to another, we actually need a channel at which we want that mail to pass through. So probably through the aeroplane or through the delivery boy. Let me say, yes, through delivery boy. Just take a bicycle around, then throw it up to the address box or something. So that's actually the port. That's actually what the port signifies. And what we have here is that Nmap actually try to give us a port at which this PostgreSQL is actually a database. The system utilizes it. That is why it is on by default, and it is open. Say it is open presently, which means that anyone can actually communicate to this my system using this port. Communication can take place, and they can get through the system through the PostgreSQL service that is running. So that is one essential, let me say, important aspect of PostgreSQL. Alright, we have Nmap. I'm going to create a note specifically on this. A note is going to back this explanation up that I'm trying to do. So just in case we have some content that we don't understand, So we have Nmap right now. So we've talked about Nmap, and let's talk about trace routes. So trace routes actually allow us to know uh, how many channel, or let me say how many computers or how many network that is in between our system and the target system we want to talk to. So let us do something. So I'm going to use trace route. So probably we want to trace route to facebook.com. So which means that before we are able to talk to facebook.com, how many computers does our network pass through? Let's say how many network our requests to Facebook they actually pass through. And as you can see from here, they pass through a lot of network. So from here, this is actually our gateway, which is my Android device, is my Android phone. From there, my Android device send this my request to this network. So you can see right here, and this network also send the request to this network, and to this network, and to this network, 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 until it reaches Facebook last. Before it gets to Facebook on the request number 16, that is when we are able to get to Facebook. Because this is 9, this is 10, 11, 12, 13, 14, 15, and 16 before we reach Facebook, which means that Facebook actually have a lot of network configuration from their head that they pass on our request from one computer to another before arriving at Facebook itself. So it is very essential to understand that. So to brief and somewhat we have learned up, we've actually learned, let me say, very few but very essential thing. And I'm just going to come back in a bit. So what is a network? A network is just interconnected computers or devices that are connected together in order to share resources. And a protocol is actually a rules that guide the communication of the resources they are sharing. So before you share a resource, you need to step yourself on protocol. And one of the protocol we have is IP protocol, which is internet protocol, which means it states that a device, two device, or let me say two device on a network, before they can communicate, they need to have a particular number that identify them. That is IP. So their number can be in two form, which is can be in version 4, IP version 4, or IP version 6. And I give you the example of IP version 4 here, IP version 6 here. Also, we have a MAC address that identify the interface at which a computer is sending a request to. So that MAC address actually see serve as another, what's it called, another identify, let me say number, another number that identify which devices that one computer is using to send a request. And also I try to explain the basic concepts of TCP and UDP. That TCP is reliable. Once you send a request, just be rest assured that your request is going to reach the second computer, or let me say the target computer, except the target computer is down and the target computer is not responding. But UDP, you are not just sure, you keep sending your information, no feedback, or you just know that you've sent it. Either you get a feedback, or you don't even know. All you know is that you sent something. That's all with UDP. All right. And I show you some what's called networking commands. If you use Ifconfig, if we do that again, Ifconfig, it shows nothing but the interface, our wireless interface, and the wired interface that we have, the device that we have. You remember I said we are going to have a particular interface that which we send our request out of the computer to the target network. That interface is supposed to have an identified ID, which we call MAC address in this case. So this is the MAC address. So this is actually MAC address right now. So we have three addresses. If you look at, we have the IP address, we have the IP version 4 address, IP version 6 address, and the MAC address. Is very very important to understand, to know what about. And I actually talk about the basis of subnets, how you can subnet a network. I say this 255.255.255, it means that the host has actually taken it, and the zero is for the client, with the client. So it means that the network, sorry, this is a network bit, the network has actually taken it, and this is actually for the host. So let me be technical here so that I won't just be talking and not be technical. And to calculate it, so we remove the zero, which is the network bit from it, and the broadcast bit from it, and I said it's remaining 223 devices that can actually connect to this network. So broadcast address allow you to know the number of devices that can function well, or the number of addresses that can be assigned two devices on your network, to host on your network. I need to be technical here, for God's sake. All right, so the broadcast address actually means the address at which the network is going to use to flood out packet, to send message to everybody on that network. Say hello, everybody. Something is happening that you all need to be aware of. Oops, that you all need to be aware of. So this is actually so essential. I show you the IP version 4 and all like that. So what else again we talk about? We talk about the ping command that allows us to know if a particular device is running, is on, or is dead. Okay, and we talk about IP command, which works similarly to the Ifconfig, but it is a very good alternative to it. We talk about net statistics that show us network information about our system. So what server network service our system is running. As you can see, we have a lot of information that our system is running, even though we are not the one running it. So for us to view the ones that are related to TCP IP protocol, we can do net stats tag, then T for TCP, U for UDP. Then when you press enter, you can see it brings those ones that are associated with TCP and those ones that are also associated with UDP. Sorry for that. Alright, we also show about Nmap, network map, which allow us to know which service. We can even use google.com, which allow us to know which service is running on a particular server. So what ports is open to us. You can see it say Google is running HTTP server, which is Hypertext Transfer Protocol for website design, and also which is running on port 80. So that is actually, and I told you that port is actually a channel at which communication take place. So the channel that we use after identifying each other with numbers, then the channel that we use to send the information is actually the port. So it's using HTTPS, which is another version of HTTP, which is a secured. The S actually stands for secure, and it's using port 443, which is actually the TLS trans. What's when TLS? I say TLS now. Yeah, I think transmission layer protocol is secured. Yeah, transmission layer secure or something like that. So those are the things that we've actually learned. So that's it. The next tutorial we're just going to move. I think, what do we have in the next tutorial? Okay, we have file systems and permission. All right, see you in the next tutorial, guys.